Right. Let's talk about that moment. You're staring at your insulation tester, and the numbers staring back at you make absolutely no sense. If that sounds familiar, you're in the right place. We're going to dive into how you can troubleshoot your device and, more importantly, get that confidence back in your readings.
And this is the million-dollar question, isn't it? Is it me, or is it the instrument? You know that feeling of doubt when a test just goes sideways? It's frustrating, for sure, but it happens to everyone. And let's be real, getting it wrong has consequences. You could misdiagnose some seriously expensive equipment, or even worse, miss a critical safety issue.
Okay, let's really get into this feeling. We're calling it the confidence crisis. It's that sinking feeling in your stomach when the one tool that's supposed to give you clear, hard answers suddenly seems to be speaking another language, and your whole job just grinds to a halt. I mean, does this sound familiar or what? You're all set, you're ready for a solid reading, you hit that button, and the display just goes nuts. The numbers are jumping all over the place, they're not stable, they don't seem to mean anything, and boom, your entire diagnostic process is thrown right out the window. And here is the most important thing to remember. If you have felt this way, you are not alone. This is not a rookie mistake. This is a challenge that even the most seasoned pros run into. So the key isn't trying to avoid it, it's having a game plan for when it happens. So, how do we solve this puzzle? Well, the first step is to figure out where to even look. The problem almost always falls into one of two big buckets. It's either something going on in the environment around you, or there's an actual fault with the instrument itself. And this chart really breaks it down perfectly. Over on the left, you've got external factors. We're talking things like humidity causing issues, or maybe just some grime on your connection points. On the right, you've got instrument faults, things like a low battery messing with your voltage, or maybe your test leads have seen better days. Pro tip, always, always, always rule out the external stuff first. It's usually the culprit. To keep yourself from just randomly guessing and hoping for the best, you need a system. A simple, repeatable checklist you can run through every single time you get a reading that makes you scratch your head. This is how you go from confused to clear. And here it is, your first line of defense. Before you even think about blaming the tester, number 1, check your connections. Are they tight? Are they clean? Take a good, hard look at your leads. Number 2, check the environment. Is it super muggy in there? High humidity can absolutely wreck high voltage testing. And finally, number 3, check the instrument itself. Is the battery fresh? Are you on the right voltage setting? I'm telling you, more often than not, these 3 steps will solve your problem. So what does this all add up to? Well, when you start using this kind of methodical approach, you're not just fixing one bad reading. You're actually building a process, a system that makes sure you can trust your results every single time. And that is what lets you test with real confidence. And this right here, this is the real secret. Confidence doesn't come from having some magical, perfect instrument that never messes up. Nope. Confidence comes from having a perfect process, a process that lets you figure out what's really going on fast, whether the problem is outside or inside the box. So let's lock in these 3 principles. First, always start with the simple stuff, connections and environment. Second, don't just start changing a bunch of things at once. Isolate each variable one at a time so you know exactly what fixed it. And maybe most importantly, learn to trust your troubleshooting process. The first number on the screen might be a lie, but your process will get you to the truth. You see, by turning that moment of pure frustration into a structured, simple checklist, you take back control. You're not guessing anymore. You have a clear path to a reliable answer. So the only question left is, are you ready to put these steps to work and start trusting your tester again? Sometimes the most important tools are the ones you don't think about every day. Take this little box, for example. It might not look like much, but it plays a massive role in electrical safety. Today, we're going to dive into the Metrel A740 Calibration Box, a device that answers a really critical question for any pro out there. And that question is, how do you test your tester? It kind of sounds like a riddle, right? How can you be sure the tool you use for measuring is, well, accurate? When you're dealing with electricity, getting that answer wrong is just not an option. Because really, that's what this all boils down to. It's a trust test. If you're a pro working with insulation testers with high voltage gear, you can't just cross your fingers and hope your readings are right. You have to know, for sure. And we're talking about some seriously high stakes environments here. I mean, being off by just a tiny fraction can set off a whole chain reaction of failures. We're talking catastrophic equipment damage, expensive downtime, Or, even worse, major safety hazards. So in this world, precision isn't just a nice to have, it's an absolute must. Okay, so how do we tackle this problem of trust? How do you actually verify your verifier? Well, the answer is surprisingly simple, really elegant, actually. Let's break down exactly how this little box works. All right, so what exactly is this thing? The best way to think about the A740 is like a tuning fork, but for your super sophisticated electrical tester. You know how a musician strikes a tuning fork to get that perfect known note? Well, an electrician uses this box for the exact same reason, to get a perfect known resistance. It's how you make sure your instrument is perfectly in tune. And using it is just so straightforward. Seriously, it's a piece of cake. You just connect your insulation tester, turn the dial to pick a resistance value you want to check, and then you take a reading. If the number on your tester matches the number on the box, boom, you know your gear is accurate and ready to go. It's really that simple. But don't let that simplicity fool you. It hides some pretty impressive engineering. So, what actually gives this little box its power? What makes it such a reliable benchmark? Let's peel back the cover and look inside at what makes it tick. Okay, so the heart of this thing isn't some crazy complex computer chip. Nope, it's 4 incredibly precise, high-quality resistors. And these aren't your run-of-the-mill parts. They are specially engineered to give you super stable, known resistance values. We're talking to range from 10 megaohms all the way up to a whopping 10 gigaohms. And that range is so critical because it covers exactly what you need to check the health of insulation on everything from huge industrial motors to high-voltage power lines. It makes sure your tester is spot on, right where it counts. And get this, it's built to handle some serious juice. The A1740 is rated for up to 5 kilovolts, 5 kV. That means it can safely and accurately check those heavy-duty, high-voltage insulation testers that you see in big industrial plants and utility companies, and it doesn't even break a sweat. Now, here's the number that really defines its reliability: a calibration accuracy of just 1%. That is an incredibly tight tolerance. What that really means is you can be absolutely confident that the reference value this box is giving you is darn near perfect. It's the kind of true, reliable benchmark you need for your gear. It's also clearly built for life in the field, you know? It works reliably whether it's hot, cold, humid, whatever. And check this out, it's only 120 grams. It's super lightweight, comes in a tough plastic case. It's the kind of tool you can just toss in your bag and take on site without a second thought. The A1740 is designed to work perfectly with a whole lineup of Metrel's advanced testers. We're talking everything from their top-of-the-line tera-ohm testers right down to the super versatile Eurotest series. This one little box becomes the gold standard for all of them, making sure the entire family of instruments can be trusted to get the job done right. Okay, but here's where it gets really cool. This device, it has a secret identity, a clever second job. Its purpose goes way beyond just checking up on other tools. So the A1740 is really a 2-for-1 deal. On one side, it's a verifier. It gives you that solid, known reference point we talked about. But on the other side, it's a simulator. You can actually use it to pretend to be a specific wire, or a cable, or an insulator. Think about how useful that is. You can set up test scenarios, demonstrate how things work, or use it for training, all without having to mess with actual, live, high-voltage equipment. That's a game changer. So what you've got here is both a verifier and a simulator. It's a tool for certainty, and it's a tool for training. That's 2 absolutely critical functions for any serious pro, and it's all packed into this little device that weighs just 120 grams. I mean, that's pretty much the definition of an essential piece of kit for the field. And that really leaves us with one final thought. Our whole world runs on electricity, right? This invisible, incredibly powerful force. In a world like that, tools like the A1740, they do more than just measure resistance. They give you confidence, they give you safety, they give you certainty. And it really makes you stop and think, in this line of work, what's the price you can put on certainty?